Imagine prompting an AI to draw a picture of sheet music.
Right, which sounds pretty standard at first.
Yeah, but I don't mean asking an AI to write a song and save it as an audio file. I mean literally asking an image generator to draw a visual picture of notes scattered across a staff.
Just a static image file.
Exactly. A JPEG. Now, imagine that through this totally bizarre, intensely human-guided series of digital translations, that single static JPEG evolves into a massive, full 3-minute song.
Oh, and it features a wailing tenor sax solo, which is just wild.
Totally wild. And then, just when you think the experiment is over, the creator takes that final audio file and somehow forces it to transform back into readable sheet music.
I mean, it sounds like a gimmick, right? Or some weird art installation.
It really does.
But this is actually a highly structured operational reality right now. We're looking at a system that completely shatters the traditional boundaries of how music is written, recorded, and archived.
Welcome to the deep dive. If you are listening to this right now, you might be a studio musician trying to figure out where the industry is going.
Or maybe you're just someone fascinated by the absolute bleeding edge of technology.
Right. And we have an incredible stack of sources today. We're looking at a collection of workflow addendums, these incredibly dense copyright briefs, and highly detailed pipeline diagrams.
And this is all from a project called the LCS Translational Composition Pipeline.
Yeah, which stands for Langocore Compositional Systems, developed by Kolozsvary.
So the mission of our discussion today is to explore exactly how this human-AI collaboration actually functions on a technical level, because it is creating an entirely new kind of recursive music creation.
Right, recursive, like a loop.
Exactly. We're moving away from the old paradigm where a song is just a static file locked in time on a vinyl record or a hard drive.
Yeah, instead we're moving toward the concept of a song as a living, breathing idea that constantly changes forms, jumping from image to code to audio and back again. Okay, let's unpack this, because we need to start at the very beginning of the pipeline, the spark of the idea.
The visual seed.
Right. The sources show that this entire massive, complex project started with a ridiculously simple text prompt. The creator literally just typed into an image generator asking for a picture of 32 bars of piano sheet music.
And the parameters were pretty specific, right?
Yeah, they asked for neo-soul genre, ballad style, in C major, at 66 beats per minute.
And the most important thing to understand right out of the gate is how the AI handled that request.
Because it didn't just search Google Images.
No, exactly. The system did not go into a massive database, find an existing copyrighted neo-soul score by D'Angelo or Erykah Badu and just pull it up to display.
Right.
It used what the documentation calls probabilistic fusion.
So it's essentially hallucinating a document based on statistical probability. It's like it's asking itself, if I were a piece of paper, what would I look like?
That's a great way to put it. The model has learned visual and structural patterns. It knows the general layout of sheet music, the staff lines, the treble and bass clefs.
And it knows the genre, right?
Right. It knows the harmonic tendencies of neo-soul usually involve a lot of ink on the page because of complex extended chords. And it knows the visual appearance of 66 BPM ballad usually implies a certain density of notes.
Okay, wow.
So it synthesizes all those constraints and draws a visually plausible image.
But it's not real sheet music.
Exactly. It occupies this really weird hybrid space. It's not an actual playable score authored by a human composer, but it contains enough structural truth to serve as what the creator calls a visual score seed.
So is this like giving an architect a mood board instead of a blueprint?
Oh, that's interesting.
Because I can see how the image have the right vibe. The aesthetic is totally there. But if you actually hand that picture to a builder to construct the house, you're gonna find out the stairs lead directly into a brick wall.
Right, they lead absolutely nowhere.
Yeah, looking at the source addendum, it explicitly notes that these AI-generated images are deeply flawed. I mean, they have rhythmic inconsistencies. The measures don't always add up mathematically.
And there are incredibly awkward chord voicings that a human hand could barely reach. But what's fascinating here is that the imperfection is the entire point.
Really? The errors are the point.
Yeah, it is the exact reason why the human element is absolutely required in this pipeline. The system is generating raw, untamed source material.
So if it were perfect, we wouldn't be needed.
Exactly. If the AI generated a flawless, finished, perfect symphony, the human is reduced to being just a passive consumer. You push a button, you get a song.
Right.
But because the AI generates this slightly broken, highly suggestive visual seed, the human has to step in and become an interpreter, a fixer, and a director.
You have to, like, redesign the staircase so it actually goes to the second floor.
Yes, which leads directly into the next phase of the project, the translational chain.
Because that visual score is stuck inside a JPEG.
Right, and your DAW cannot read a JPEG, so how does that visual seed actually grow into music you can hear?
Let's follow the friction of this process because it is intense. You don't just drag and drop a picture into an audio generator.
No, not at all.
The human has to manually interpret that flawed image and convert it into ABC notation.
Right, which is quite the task.
Yeah, for anyone who hasn't messed around with old school digital music formatting, ABC notation is basically text-based music code. You are literally typing out letters and symbols representing notes and durations so a computer can read it.
The human is doing heavy lifting here. They are looking at the visual seed, deciding which awkward voicings to keep, fixing the rhythmic mathematical errors, and typing it into code.
Okay, so now we have code.
From there, the ABC text code is translated into a standard MIDI file.
But the MIDI isn't the final stop. The flowchart shows that MIDI file then gets routed into a software called EZkeys 2 for something called a chord reduction.
Yeah, that step is crucial.
But why take the time to build a complex MIDI file just to reduce it? Why not just dump the MIDI straight into the final AI generator?
Well, if you feed an overly complex, messy MIDI file directly into a downstream audio generator, the AI often gets overwhelmed and hallucinates sonic garbage.
So it needs a clean slate.
It needs a stable foundation. EZkeys 2 acts as a filter. The human uses it to simplify all that complex data into a clean foundational audio bed.
Like a basic WAV file.
Exactly, a basic WAV file that captures the core harmonic progression without any distracting embellishments.
Okay, and then, and only then, is that stabilized WAV audio file uploaded into Suno.
Right, the AI music generation platform.
So it serves as the audio prompt. The human adds some text directions about instrumentation, and Suno takes that foundational piano bed and explodes it outward.
And the result of that massive chain of translations is stunning. That initial 32-bar visual sketch, having passed through text code, MIDI, chord reduction, and audio, was transformed by Suno into a fully expanded 3-minute plus cover version.
Wow.
The AI added full instrumentation. It generated an entire, incredibly emotive tenor sax performance that did not exist anywhere in the original visual prompt.
Wait, stop translating it that many times. From a picture to text to MIDI to audio to an AI generator.
I know, it sounds crazy.
Doesn't that completely destroy the original song? It feels like taking a beautiful Shakespeare sonnet, running it through Google Translate into Japanese, then into Russian, then into Spanish, and back to English.
Right, usually you just end up with absolute gibberish.
Exactly.
Oh.
How can anyone claim this is still the same piece of music? Doesn't it lose its soul?
The creator tackles that skepticism head-on in the project's manifesto. The core philosophy of LCS is that music no longer has to be imprisoned in a single format. The artistic identity of the piece, of the soul you're talking about, actually survives the translation process. The creator coined a term for this: translational score genesis.
Translational score genesis. So the translation isn't degrading the music.
Not at all. The essence of the melody, the emotional pacing of that 66 BPM neo-soul ballad, it persists specifically because the human is guiding each step.
So the human is acting as the guardian of the song's identity.
Yes. The translation reveals fresh possibilities hidden inside that original visual seed, like finding out a poem actually works beautifully in another language if the translator is skilled enough.
But that requires a massive amount of active management. The human can't just be asleep at the wheel.
Absolutely not.
To prove that the music doesn't just get garbled by the machines, the sources give us a really specific, highly technical test case.
Yes, addendum 2.
Right. It shows what happens when the creator hits a fork in the road and has to make a critical creative choice to save the flavor of the genre.
Yeah, addendum 2 details this experiment. They took an ABC2 notation object, basically a very dense chunk of musical code, and ran it down 2 completely different rendering branches just to see what the software would do to it.
Okay, so branch A was the direct harmonic interpretation route.
Right.
The goal here was to preserve the vibe at all costs. The sources show this path maintained a rich, slightly faster 77 beat per minute neo-soul color.
It kept all the complexity.
Yeah, it retained all these incredibly complex, spicy jazz chords. We're talking E flat major 7s, B flat 7s, GC's 4s. It felt lush and alive.
But branch B was a completely different story. This was the Langocore MIDI branch.
And what happened there?
Well, when they sent the exact same starting code down this path, the software aggressively abstracted it. It compressed the music into a bare skeletal framework.
Oh, wow.
It dropped the tempo down to a sluggish 50 beats per minute.
Uh-huh.
And it stripped away all those complex jazz chords, reducing the harmonic structure to mostly just F6 and G minor.
I mean, that sounds like a depressed dirge played on a toy piano.
It really does.
Here's where it gets really interesting. The tools themselves have absolutely no taste.
0.
They have no idea what is best. The system doesn't know if you're trying to write a lush romantic ballad or a bare-bones skeleton for an avant-garde electronic track.
It just offers mathematical options.
Right. If you want all that rich neo-soul color, you have to possess the musical knowledge to actively choose branch A. If you want a blank, slow skeleton to build something totally new on top of, you choose branch B.
If we connect this to the bigger picture, this completely dismantles the popular argument that using AI in music is just lazy.
Hold on.
It destroys the idea that it's just pushing a button and walking away. Authorship within this LCS workflow is intensely active.
The human is functioning as a curator, a director, and a highly technical editor.
Exactly. You have to know music theory well enough to look at the data from branch A and the data from branch B, analyze the harmonic structure, and decide which ones serve the emotional goal of the project.
You aren't letting the machine drive.
Oh,
You are fighting the machine for the steering wheel at every intersection.
that's exactly what it is.
So you curate the flow, you choose your branches, you survive the translations, and eventually you get this massive, beautiful Suno WAV file with a wailing tenor sax. You put it on Spotify and the song is finished.
Right.
No.
That is where this pipeline turns from a straight line into a circle.
A circle. Because the sources detail something called the return to score branch in Addendum 1.
Yes, this is where it gets crazy.
Once you have that final polished audio file, the process actually violently reverses direction. The music goes from the finalized audio format back into notation.
They utilize a specialized tool called Transcription AI to execute this reverse engineering.
But pulling sheet music out of a dense, multi-track audio mix is notoriously difficult, isn't it?
Oh, it's incredibly hard, which is why the documentation outlines 3 very distinct recovery modes depending on what the human needs.
Okay, so the first is 8A, direct transcription.
Right.
The documentation calls this a diagnostic audio map. It literally attempts to transcribe every single frequency and transient happening in the full mix.
Which is a nightmare. I mean, if you have a piano, a saxophone, a sub bass, and a drum kit all playing at once, forcing all of that onto a single piece of sheet music creates a visually cluttered, unplayable mess.
It's useless.
Well, it's useful for a producer trying to diagnose a frequency clash, but you could never put it on a music stand.
That's why they use 8B, the arrangement mode.
Exactly.
The notes explicitly flag this as the preferred method when dealing with a heavily mixed WAV file from Suno. It cleans up the chaos.
It ignores the drum transients and the overlapping noise and creates a clean, playable, unified piano reduction of the entire track.
And then finally, there's 8C stem-based transcription.
This is a surgical tool. You use this strictly when you want to isolate one very specific element.
So like if you want to recover the exact notes of precise phrasing of that AI-generated tenor sax solo so you can hand the sheet music to a live human saxophonist to play in a studio,
Yeah.
you use 8C.
Yes.
We have to pause and look at what just happened. The output of the AI audio generator literally becomes new sheet music.
And because it's sheet music again, it can be fed right back into the very beginning of the pipeline.
It becomes a new seed.
Exactly. You can mutate it into ABC code, render it into MIDI, slow it down, change the chords, and send it through the whole machine again.
The process never actually has to end.
It is a perpetual motion machine of creativity. The implications for composing are staggering.
But
building a perpetual motion machine using AI tools and existing software platforms inevitably crashes into a massive, unavoidable, real-world problem.
right, who actually owns the rights to a piece of music that is bouncing infinitely between human curation, EZkeys software, Suno generation,
Yeah.
and songnscription AI?
The huge issue.
The legal reality. The sources include an incredibly dense ownership and copyright brief that tackles this exact nightmare.
And it relies on current evolving guidelines from both the Canada Copyright Act and the US Copyright Office.
And surprisingly, the baseline rule it establishes is actually quite clear. The strongest copyright claim belongs strictly to the human-authored decisions.
The law fundamentally does not care about the machine's effort.
Not at all.
Your strongest claim of legal ownership covers the initial text prompts you wrote, the manual editorial revisions you made to the sheet music when the AI drew awkward voicings, the ABC code you physically typed out, and the final assembly of the project.
Okay, so what has the weakest claim?
Purely machine-generated outputs, like a raw, completely unedited Suno render straight from the server, have the weakest, most legally uncertain ownership claims imaginable.
This brings up a critical concept from the brief called the Studio One factor.
Right, Studio One being a popular DAW or digital audio workstation.
Yeah, and it highlights that using your DIW is central to establishing your legal claim.
The brief refers to the DAW as an authorship amplifier. Think of the DAW not just as a recording tool, but as a legal fortress.
A legal fortress, I like that.
Every time you import an AI-generated stem into your session, every time you chop a transient, edit the timing, layer a new instrument over it, or automate the mix, you are laying down a brick of copyright protection.
Because you're proving you did the work.
Every single click provides hard, documented evidence of human creative control. It proves the work is a curated human expression, not a cold machine output.
So what does this all mean? If you are a creator listening to this right now, and you want to use a massive pipeline like this without getting sued or losing the rights to your own song, how do you practically protect yourself?
Well, the documentation provides a survival guide. First, you must maintain a dedicated chain of title folder.
Like a detective's murder board of evidence.
Exactly like that. You need to save your initial prompts. You need to save your ABC text files, the MIDI exports, and your project bounces from your DDAW at every major evolutionary stage of the track.
Just keeping all the receipts.
Yes. If your copyright is ever challenged, you need to be able to physically prove the sequence of your human interventions.
Okay, what's next?
Second, you must ensure with absolute certainty that you are not feeding the AI any copyrighted third-party source material at the beginning of the pipeline.
Right. If you put a copyrighted image of a John Williams score into the Visual C generator, the AI output at the end inherits that massive infringement risk.
You cannot launder stolen music through an AI pipeline and claim it as your own.
The machine doesn't wash away the original copyright.
It amplifies the liability.
Thanks.
Third, you have to obsessively check the terms of service for every platform you touch. Contract law matters just as much as copyright law in this workflow.
For example, Suno's terms explicitly state that if you are paying for their Pro or Premier tiers, you are granted commercial rights to the outputs.
Right, but if you use the free tier, you do not own commercial rights. If you build a massive hit song using a free tier output, you have a massive legal vulnerability.
Okay, so assuming you followed all the rules, you paid for tiers, you kept your murder board of evidence, and you finally released the track on YouTube or Spotify, how are you supposed to credit it? You can't just say, written by me.
The safest public description, according to the legal brief, is to explicitly state the boundaries of what the human did.
Like in the metadata.
Exactly. You've described the work in the metadata as, quote, human-authored original concepts, arrangement, and DIW production, utilizing AI-assisted elements.
So you are claiming the workflow, the curation, and the editorial control while transparently acknowledging the machine's role.
It's all about documentation and intent.
What an absolutely wild journey this is.
It really is.
I mean, we started with the bizarre premise of just asking a computer to draw a picture of 32 bars of sheet music. We watched that flawed visual transform into raw text code, survive a massive simplification process, expand into a fully realized audio track with a phantom saxophone player, and then violently loop all the way back into readable sheet music.
All while the creator is carefully navigating the absolute bleeding edge of international copyright law to protect their work.
It is a masterclass in what modern composition is becoming. It requires a completely different skill set than just playing an instrument. If you are listening to this right now as the learner and wondering if AI is going to steal your studio job, I think the biggest takeaway from this deep dive is that AI is definitely not an instant song button.
No, not at all.
It's a massive, complex, recursive toolkit.
Yeah.
And ironically, it actually rewards deep musical knowledge. It demands critical thinking and aggressive curation.
Right, because the AI didn't know if the lush jazz chords of branch A or the skeletal dirge of branch B was better for the song.
Exactly. It desperately needed the human to know the difference.
I want to leave everyone with a final thought to ponder, something that builds on this entire concept of the recursive loop.
Let's hear it.
If a song can be constantly cycled from an audio file back to musical notation, tweaked by a human producer, morphed by an AI generator, and then run through that exact same cycle again indefinitely, at what point does a piece of music truly become finished?
Wow.
Or, in this new age of translational composition, is every recorded song you will ever hear just a temporary snapshot of an immortal, ever-changing idea?
A temporary snapshot. That really makes you rethink what it means to actually write a song.
It changes everything.
The next time you look at a piece of sheet music, just remember, you might not be looking at the final blueprint of a finished masterpiece. You might just be looking at a mood board, waiting for the translation to begin.